So, I am T. Lakshman Reddy. Today we discussed about Thermodynamic Chapter Part 1. In this chapter, mainly we have to discuss about basic terminology and thermodynamic properties, thermodynamic functions, and enthalpy, uh, heat, and state functions. Okay, thermodynamic process, uh, laws, zeroth law, and first law of thermodynamics, and isothermal reversible expansion of ideal gas, work done in cyclic process, Carnot cycle, and heat capacity, relation between Cp and Cv. These are the Joule-Thomson effects. These are the main topics in this chapter. Today we are going to discuss about in part 1 thermodynamics. Thermo means heat, uh, dynamic means motion. Dynamic means motion. You have to observe in slide clearly everything. So the branch of physical chemistry that deals with the transfer of heat either in a physical or chemical process is called thermodynamics. That means the physical process, that is heat, either in a physical or chemical matters, is called thermodynamics. For example, you have to see H2O in liquid state, it undergoes H2O in vapor state. That in that reaction, heat is required. That means the liquid transferred to vapor. That means heat is required. That is the physical process. H2O vapor undergoes H2O liquid. That means vapor condensed and form a liquid state. That means heat is liberated. Heat is liberated. HCl plus NaOH, that is the chemical reaction, that is the neutral reaction. What happens in between these two reactions? Salt is formed, NaCl is formed and water is liberated. So heat is liberated. Here heat is liberated. What is the basic terminology in thermodynamics? First of all, what is the system? It is nothing but the portion under study which is separated from the remaining universe by a boundary surface. What is the system? It is nothing but the portion under study which is separated from the remaining universe by a boundary surface. Types of systems. What are they? Open system, the system which exchanges both heat and matter with the surroundings is called open system. What is the open system? The system which exchanges both heat and matter with the surroundings is called open system. That is best example. That one is a tea in an open cup. That means heat expands in surroundings, link with the surroundings, exchange with the surroundings. Next one is the closed system. The system which exchanges only heat but not the matter with the surroundings is called closed system. What is the closed system? The system which exchanges only heat but not the matter with the surroundings is called closed system. Hot tea in a conical flask or closed cup. Hot tea in a closed cup. That means here only heat, in which exchange only heat but not the matter. The with the surroundings is called the closed system. Next one is the isolated system. You have to observe in isolated system. In isolated system, what is the isolated system? The system which neither exchanges heat nor matter with the surroundings is called isolated system. The system which neither exchanges heat nor matter with the surroundings is called isolated system. Tea in thermal flask. Tea in thermal flask. Homogeneous system. A system in which all the components are present in the same phase is called homogeneous system. A system in which all the components are present in the same phase is called homogeneous system. Best example is the water plus alcohol in system. Heterogeneous system. The system in which the components are present in different phases is called heterogeneous system. Thermodynamic process. The properties of a system whose magnitude changes during the thermodynamic process. During the thermodynamic process. Intensive property. The property of the system which depends upon nature of the material but not the quantity is called intensive property. The property of the system which depends upon nature of the material but not the quantity is called intensive property. Example: density, surface tension, viscosity, concentration, refractive index. Extensive property. The property of the system which depends on the quantity of the material present in it is called as extensive property. What is the extensive property? What is the extensive property? The property of the system which depends on the quantity of the material present in it is called its extensive property. Example: mass, volume, pressure, number of moles. Pressure, number of moles. Extensive property is the property of the system which depends on the quantity of the material present in its is called its extensive property. Example: mass, volume, pressure, number of moles. Number of moles. Next one is you have to observe in the slide clearly thermodynamic functions. Thermodynamic functions or what are the thermodynamic functions? The functions which are associated with thermodynamic process are called thermodynamic functions. What are they? Internal energy, enthalpy, heat, work, Gibbs energy, entropy, Helmholtz function. Helmholtz function. Thermodynamic variables. The variables which are changed or undergo the thermodynamic process are called thermodynamic variables. Independent variables. What are the independent variables? The variables with changes independently are called independent variables. Dependent variables. The variables which depends on the independent variables are called dependent variables. Example: volumes. Okay. Again, I repeat. What are the thermodynamic functions? The functions which are associated with the thermodynamic process are called thermodynamic functions. What are they? Internal energy, enthalpy, heat, work, Gibbs energy, entropy, Helmholtz functions. Thermodynamic variables. The variables which are changed or undergo changes during the thermodynamic process are called thermodynamic variables. Thermodynamic variables. Independent variables. The variables which changes independently are called independent variables. Example, temperature, pressure. Dependent variables. The variables which depends upon the independent variables are called dependent variables. Dependent variables. Example, volume. Internal energy. The minimum energy associated with the system for its existence is called its internal energy. E is equal to uh, translational energy plus rotational energy plus vibrational energy plus kinetic energy plus potential energy. Enthalpy. What is the enthalpy? Total heat quantity H. It denotes with H. The total energy associated with the system, part of which is its internal energy, and remaining is the energy required for mechanical work. The total energy associated with the system, part of which is its internal energy, and remaining is the energy required for mechanical and work. H is equal to E plus PV. H is equal to E plus PV. Relation between delta H and delta E. What is the delta H? Delta is the enthalpy. H is the heat. Here we know H is equal to E plus PV. State 1, you take 1. H1 is equal to E1 plus P1. State 2, H2 is equal to E2 plus PV2. From these two, 2 minus 1, H2 minus H1, E2 minus E1 plus PV2 minus PV1. Delta H is equal to delta E plus P of V2 minus V1. Delta H is equal to delta E plus P delta V. Delta H is equal to delta E plus P delta V. We know PV is equal to nRT. P delta V is equal to delta nRT at constant PV. From 3 and 4th equations, delta H is equal to delta E plus delta nRT, where delta H is equal to change in enthalpy, delta E is equal to change in internal energy, delta V is equal to volume change, delta N is equal to change in number of moles. Again, I repeat again. What is the relation between delta H and delta E? H is equal to E plus PV. H1 is equal to E1 plus P1, that is just state 1. H2 is equal to E2 plus PV2, state 2. H2 minus H1 is equal to E2 minus E1 plus PV2 minus P1. Delta H is equal to delta E plus of P of V2 minus V1. Delta H is equal to delta E plus P delta V. PV is equal to nRT, P delta V is equal to delta nRT. Delta H is equal to delta E plus delta nRT, where delta H is equal to change in enthalpy, delta E is equal to change in internal energy, delta V is equal to volume change, delta N is equal to change in number of moles. Next one is the work. What is the work? You see in the figure clearly what is the work. Observe in figure clearly. P pressure external and V1, V2 and DL. Here P external is equal to F by area, total area. F is equal to P external into area, P external into area. Work is equal to F into displacement. F into displacement. P external into area into displacement. P external into delta V. W is equal to P external delta V. W is equal to P external delta V. Mechanical work or pressure minus volume work. Sign conversations. W done on the system plus W plus W. W is equal to P external delta V. P external delta V. W done by the system negative sign. W is equal to P external delta V. P external delta V. Heat Qr nu. Heat is the form of energy that is accompanied by change of temperature. Accompanied by the change of temperature. Heat absorbed by the system is positive, that is Q. Heat released by the system is negative, B. Units joules, ergs, calories. Joules, ergs, calories. 1 joule is equal to 10 to the power 7 ergs. 1 calorie is equal to 4.184 joules. Again, I repeat. Here, you observe in figure clearly. P external top of the picture, and the dotted lines total is V1. In these dotted lines, two layers are there. Lower layer is the V2, upper layer is the DL, denoted by DL. What is the mathematical equation? P external is equal to F by area. F is equal to P external into area. Work is equal to F into displacement. P external into area into displacement. P external into delta V. W is equal to P external delta V. That is compression. That is compression. Mechanical work or pressure minus volume is work. W done on the system, that is positive sign. W is equal to P external delta V. P delta V. W done by the system with negative sign, that is negative sign of P delta V. Heat, QRQ. Heat is the form of energy that is accompanied by change of temperature. Heat absorbed by the system is positive. Heat released by the system is negative. Units joules, ergs, calories. 1 joule is equal to 10 to the power 7 ergs. 1 calorie is equal to 4.184 joules. Next one is the so today we discussed about these things. What are they? Thermodynamics. In thermodynamics, first one is what is the uh, thermodynamics and basic terminology. What are they? Open system, closed system. What is the system? Isolated system, homogeneous system, heterogeneous system. Thermodynamic properties. What are the properties? Intensive property, extensive property, thermodynamic functions, thermodynamic variables. What are the variables? Independent variable and dependent variable, and internal energy. Next one is the enthalpy. Relation between enthalpy delta H and delta E and work. These are the today's topics here clearly. explain to you